Hi students, I am continuing with the vertical motion. In the next example or in the next application, what I will do is I will release a particle from rest from a height h. I am releasing it from a height h. It will fall down to ground. It will come down to ground. While coming down also, we will follow the same sign convention. What is that sign convention? We will take up upward as a positive. We will take up upward as positive. You observe while it is falling down, let us suppose at an instant its velocity is v. Clearly, velocity will be negative, and we know acceleration that is acting in downward direction, which is also negative. Hence, velocity and acceleration are in same direction. Such motion will give you accelerated motion, isn't it? So downward motion of the released body is going to be an accelerated motion. Now, let us suppose the particle has traveled for a time interval of t, and then it has traveled a displacement of h1. I would like to get the expression for h1 and velocity v as a function of time t with the help of same equations of motion. Which equation you want to use? V equal to u plus at is the first equation in our hand. Implies we know already this velocity is going to be downward, means velocity will become minus v, which is equal to initial velocity will be 0, and we know acceleration will be minus g into t. Implies velocity will become equal to gt. This velocity is going to be downward. That's what it shows. It is an accelerated motion. Because as time increases, velocity will increase. Next thing that I would like to get is h1. We know s equal to ut plus half a t square. Implies displacement in downward direction, because h1 is a downward displacement. Then s will be minus h1. How much is initial velocity? 0. How can you say that? It has been released from rest. So u will be 0 minus half g t square. Implies h1 is equal to half g t square. So the downward displacement will be equal to half g t square. How much time it will take to reach the ground is the next question. Time for downward journey. Let us suppose it has reached the ground within a time interval of t equal to t naught. Within a time interval, if it reaches ground, how much will be the downward displacement? The downward displacement will be equal to h, means h1 will become equal to h. So in place of h1, I can arrange h. h will be equal to half g into t naught square. Implies t naught is equal to root over 2h by g. That is the time taken to reach the ground. With what velocity it will reach the ground is the next question. Means by the time it arrives onto the ground, let us assume that its velocity is v naught. If v equal to v naught, within how much time it is reaching the ground? Within a time of t equal to t naught. So in this equation, if I want to get the expression for v naught, I have to put v equal to v naught. Then automatically t will become t naught, g into t naught. Implies v naught is equal to g into t naught will be root over 2h by g. Implies v naught is equal to root over 2gh. So it will reach the ground with a speed of root over 2gh. Within how much time it will reach? Root over 2h by g. Downward motion is going to be accelerated motion. Now, sometimes they will ask you displacement time graph, and they will ask you to plot the velocity time graph for the situation, for the case when the body has been projected in upward direction. How to plot them? For example, us try to combine both the situations. Say, I have projected a body with an initial velocity u, and then it is going down. It will reach the highest point. When it reaches the highest point, its velocity will become 0 meter per second. And after that, it will start coming down, isn't it? It will reach the ground again. Let us analyze this situation. Is it okay? Within how much time it is going up? Within a time of u by g, isn't it? So the time taken for upward journey is t naught, which will be equal to u by g. How much height it will go? H max, which will be equal to u square divided by 2g. Now it is at a height of u square divided by 2g, and it is at rest, isn't it? When it has gone up to maximum height, it is at rest. So it will start its journey in downward direction from rest position. How much time it will take in order to come down? Isn't it? That is next question. H square here will be u square by 2g. Do you remember I have derived an expression for time taken to come down in my previous example? How much is the time taken? T will be equal to root over 2h by g. In place of h, I need to use u square divided by 2g, implies root over 2 by g into u square divided by 2g. 2 gets cancelled, it will become u by g. What it says? It says that the time taken for upward journey will be u by g, the time taken for downward journey is also u by g. Within the same time, it will come down. That is one more important result. Next, with what speed it will come down? Do you remember the expression for the speed with which it will come down? Root over 2gh, which will be equal to root over 2g into, how much is h value? U square divided by 2g. 2g gets cancelled. It will come down with the same speed. Have you observed? I have once projected the body in upward direction. I have observed only upward motion. Then I have released a body from rest at the top from a height h, and then I have observed the downward motion. Then I have combined both of them. I have projected it in upward direction, and then I waited till it comes down. These are the results. So let us combine or let us conclude all of them. Suppose you have projected a body with a velocity u, it will go to the top within how much time? U by g, isn't it? How much height it will go? U square divided by 2g. Next, I will release a body from rest from a height h. Within how much time it will come down? Within a time of root over 2h by g. With what speed it will come down? With a speed of root over 2gh. Now let us combine both the situations. I will project a body with a speed u, it will go up and it will come down. How much time it will take to reach the topmost point? U by g. Again, from the topmost point to ground, how much time it will take? U by g. Then the total time of journey will be, total time will be u by g plus u by g, which is equal to 2u by g. With what speed it is coming down? With a speed of u. With the speed with which you have projected the body, with the same speed it will come down. All these results are very important while making the analysis.